of all, understand the business problem, and then load your library files and read the data set and perform the pre-processing, and then apply your model, define your model. Here the model is nothing but a RNN model. Okay, now train the model and compile the model. Okay, and then test your model. Like that, we have to perform the different steps in a sequential manner. So here I'm reading the one simple sentence. Based on the simple sentence, we are going to generate the, after reading this entire sentence, you have to generate the new words. Okay, that is a problem statement here. Now here I am importing the numpy as a np and tensorflow as a tp, and from the tensorflow.keras.preprocessing as .text, import to tokenizer, and from tensorflow.keras.models import to sequential, and from tensorflow.keras.layers import to embedding and simple RNN dense layer. Okay, and then from tensorflow.keras.utils import to categorical. Okay, they are the, so sequential nothing but your our model is nothing but you are reading the input from the first layer to the last layer. Okay, we are performing all the operations in a sequential manner. That's why we are using the sequential model. And embedding in the first two, for after reading the input value, we are converting that into another format. Okay, that is word to vec. Simply it is called as a embedding. And also our model is nothing but a simple RNN model. Okay, simple RNN model. That means it contains a TANS operation. Okay, and then we are using the dense layer. After applying the whatever after applying the RNN also, we are using the ANN model. So that's why it's a fully connected network. That's why we are using the dense layer as a dense. Okay, now. And also we are going to use the two categorical to convert the whatever English words into numerical whatever characters into numerical values, numerical into English words. Okay, so that we are using the two categorical. So here we are reading the some text messages. That is this is simple text for the language modeling, and we will use it for the to train the RNN. This is our simple text message. Okay, after reading this message, we are going to after reading this one, we have to generate the new words based on the present input. Based on the present input words, we are going to generate the new words. See the output here. Okay, see the, I will show the output. Okay, this is a simple text message for the language modeling. We will use it for the train the RNN. After that, we are going to generate the new messages. Okay, new message. This is with the help of our RNN model. RNN model. We are generating the new words. Okay, now with the help of present words. This is with the help of RNN only. Okay, now. Now here see this one. This is the model. Okay. First of all, reading the information, that is the text equal to. This is a simple text message for the language modeling. We will use it for the to train the RNN. Then we are creating the creating mapping of unique characters to the integers. That means we are reading the each and every character, and that is converted into map to each some integer values. Okay. Uh, to uniquely recognize the each and every character or each and every words. So here char equal to sorted list of set of text data. That means whatever the text is there here, the text is converted to different set of words. That is set of words are going to be given to list. That list is going to be sorted. Those are assigned to characters. Then char underscore to underscore index equal to whatever the characters are there. Okay, so the characters are going to be enumerated, and that is assigned to char char colon idx. We are giving the index for the each and every character in the character words. Okay, then we are going to use the idx to character. That means we are converting the reverse order. Okay, id index to the characters. Okay, index and char index for char for char index in the idx in the idx mathematics index. Okay, idx in the char to index dot items. That means we are reading the input words, and that is converted into index values, then index value into characters values. Both are we are performing here. And then sequence equal to convert the text to integer sequence. Okay, sequence equal to char to index char for char in text messages. Okay, and what we are finding the number of parameters in the our length. So sequence of length equal to 10. Okay, and char equal to sorted list of text, list of set of text, and vocabulary size equal to length of the char. Okay, then based on this one we are having the different types of work. The size of the vocabulary equal to length of the character, and characters are there. Okay, then we are going to get the input sequence and output sequences. So here x empty string is there and y equal to empty string there, and for I in the range of 0, length of the sequence minus sequence of length. Okay, then x is appended to sequences, and y also appended to the sequences. Then we are converting the x and x equal to np dot array of x and y equal to np dot array of y. So then we are going to convert the 1 hat encoder for the y value. So y equal to 2 underscore categorical y comma and the number of classes. So based on the your vocabulary size, we are going to have the n number of classes, and this is your model. Okay, we are going to be what the model here. First of all, you read the input present information, and we are going to be perform the first operation is going to be performed embedding. Then we have to apply um, uh, multiply to weight value, and the previous node way information also be multiplied to weight value. Then that is going to be concatenate given to input for the tannage, and that tannage is going to be whatever the output is there, that is given to as a input for the next layer, and that is going to be multiplied here why, and we are going to get the output OT value. So now here the model is nothing but a model equal to sequential model. Then you have to apply the first thing is called as a embedding model dot to add of embedding. Okay, add of embedding. Okay, now so for the embedding we are going to give the input as a vocabulary size and output dimension. After applying the embedding here, we are giving the output size of this one equal to 64. So here after applying the embedding, we are getting the output in our example theory class where theory I explained that it is a 200 word. Okay, but here I'm saying it is a 64 length word. Okay, now and then input length equal to sequence length. What are the input length is there in a okay, that is a must be equivalent to sequence of the length. Then model dot add of simple RNN. Okay, now we are going to create one RNN node here with the help of the number of neurons in the RNN nothing but 128 neurons are there, and the return sequence equal to false. It does not return. And there are for all the here we are having the 128 neurons are there. For all the 128 neurons, we are not generate the output. Only on the final node only we are going to generate the outputs. That's why we are generating the we are using the return sequence equal to false. Okay, now we are not generating the output on each and every neuron. We are generating the only on the output layer only. Okay, now so at that time we are using the return underscore sequence equal to false. Then model dot add dense of vocabulary size and the activation function equal to softmax. So we are going to get the multi-class classification problem, whether it is a okay multi-class classification model. Then at that time we are using the softmax as a activation function, and based on the number of vocabularies we are going to use the number of neurons in the your dense layer. Okay, now so this is your model. Of training your model, you have to display a summary of the model. Okay, model equal to, so first of all you have to embedding, then you have to apply your model, then you have to apply your dense layer, that is a fully connect layer. Then you have to compile the model dot compile the loss function, loss equal to categorical loss function, categorical cross entropy, and optimizer equal to Adam, and the metrics are equal to optimizer. So based on your requirement, we are going to change the number of neurons here. Okay, and the number of output dimensions also here. Okay, based on these things we are going to get the different outputs. Okay, now and also based on the optimizers, based on the loss function, we are going to get the different outputs. After that, you are training the model dot fit function x comma y, x nothing but present test train data, y nothing but present. Okay, and batch size equal to 64 and epochs equal to 50. Okay, and 50 epochs we are trained. So initially we are having the more loss is less accuracy is there, and very loss is very high. Of number of epochs what happen? The number of after epochs are increases, the accuracy is going to be very high, and the loss function is going to be decreases. Okay, after each and epoch, we are updating our weight values. Okay, we discuss the what is the weight values. Okay, each and every after each and every epoch we are updating the weight values. Automatically, what happen? The accuracy is going to be very high. The loss is going to be decreases. So then we are going to generate the our text messages. Okay, so for that we are going to define one function definition of generate a new text messages with help of seed text message and number of characters. Okay, for in the range of number of characters. Okay, input sequence equal to char to character to index char for char in the seed underscore text of each and every length. Okay, input sequence equal to np dot reshape input sequence 1 comma sequence length. Okay, predicted equal to model dot predictor of input sequence verbose equal 0 and predicted of underscore char equal to index to char np dot argmax predictor. Okay, and seed underscore text equal to plus or equal to predictor of care and return C text message. This is a function simply one function is defined here to generate the message. Okay, and here the seed message is this is a your input message. This is a. We are giving the three characters word. Okay, three words are we are giving. Okay, and based on these three words, we are going to generate the our new text message. Okay, generated underscore text equal to generate the text message with help of seed with help of seed. See what is seed here? This is your input value. And how many words you have to generate? 500 words you have to generate. This is with help of our what we call whatever the with help of this function we are going to generate the all the things. Okay, and print to generate text message. Okay, what the starting word? Three characters, three words. This is a. Okay, based on these three words, we are going to generate the remaining all the 477 words. Sorry, 97 words. Okay, now. So like that, we are going to generate the text message with the help of RNN. So any doubts until now?